In this series of videos I am restoring an LRP-300 paper tape punch and reader. In the previous videos I've stripped the system down, cleaned up the chassis, tested the power supply, and in this video we'll be looking at the punch mechanism. Now in these old punches and readers, then it's the punch mechanism itself that normally takes the most beating. It's running at high speed, it's punching hundreds of thousands of holes, and it's subject to all manner of abuse. They rarely get properly maintained. They're probably better maintained these days than they were back then, and invariably they see a lot of wear, and they start punching badly or jamming, and then they're not used for many years, as this one doesn't seem to have been, and they start to seize up. So what we'll do in this video is we'll strip this down, give it a proper service, clean it, see what the condition of the actual punch head and pins are, and see if it needs any repairs. Now at the moment it seems that the paper advanced system is seized up, it won't turn, so we'll need to look at that. One interesting feature with this particular punch is, reading through the manual for it, it claims that the punch head, that's the die block and pins, can be replaced in less than a minute, which, if you're not familiar with these old machines, probably doesn't sound that impressive, but normally replacing a punch head, the dies and pins on a punch, can take quite a few hours work and needs careful realigning and whatever else. So it's quite an interesting claim. We'll have a look at that in a minute and see if that is the case. Before we start stripping this down, I thought it might be interesting just to explain how it works. If you're familiar with these, then you already know how these operate. But if you haven't seen these before, then their mode of operation might seem a bit unusual. And what we have here is a series of solenoids. So there are 9 solenoids. There are 8 for the data holes. It's an 8-bit wide tape this will go up to, and the 9th is for the sprocket hole. And the solenoids do not directly drive the pins through the paper, and the reason for that is the entire paper is only 1 inch wide, so the holes are spaced at 0.1 inches, so there just wouldn't be space to get the solenoids side by side. You couldn't get 9 side by side in the width of the tape. You could stagger them, of course, but even if you did that, you'd need quite beefy solenoids to punch through the paper at the speed this runs at, and then trying to move the plungers on the solenoids at the speeds we're talking about would need very high drive currents, real big power supplies, beefy drivers, which in turn would require bigger solenoids to put up with the power, and then the noise would be horrendous. Having 9 solenoids of that size running at the speed these punches run out would be horrendously noisy. So that's not actually how these work. So what I'll do is a quick diagram as to how these punches work. Now they do all vary slightly, but it's mostly a variation on a theme. So I'll just move the camera down. Okay, so the way this particular punch is laid out, and as I say, it is common to a lot of punches, they do vary in the detail of how they're put together, but this is a particularly nice assembly because it's very open. It's quite easy to show the individual parts and how this works. But the way it works is there's a punch pin, so we're looking side on here, and the pin's got an extension on the bottom, and the paper tape runs along the top of the pins, so it advances 0.1 inch each time a new row is selected. The pins run in a block, so there's a die block that has close tolerance holes, so the pins run quite snugly in the block. Free to slide in and out, of course, but there's not a lot of free play. And then there's a matching die block above the paper tape. And the idea is that if you want to punch a hole in the paper, you just drive the pin upwards, and then the small piece of chad is ejected and it leaves a hole in the tape. You advance the tape and then you repeat as required and punch just the holes you need. But the question is how to control the pin. As I said, there isn't a solenoid on the bottom, And the way this system works is there is a rocking block that the bottom of the pin sits in. So I'll just do a representation of it. It's not exactly how it's laid out, but we'll give you some idea as to how the overall machine operates. And there's a pivot hole at one end of this block, so this entire block can pivot around this pin. So it's fixed on the pin, and this can move up and down. And to drive it up and down, there is an eccentric and a cam on the bottom, and the main drive motor for the punch drives this cam. It's not arranged quite like this, it's actually eccentric, but it works similar to the way a piston in a car engine moves up and down. Okay, so what happens as the main motor spins, this block rocks up and down. As things are arranged here, it doesn't go very far, by the way, it's only moving by maybe 2 or 3 millimeters at the most. But as it goes up and down, as it is here, what happens is the pin slides in and out of this hole and doesn't actually get raised as this moves upwards. If you want the pin to move upwards, then what you do is you insert a thin plate into the gap underneath the pin, and that's how this actually operates. There are little fingers that sit in this groove, and if you leave the plate out, then the pin is not raised on this cycle. If you push this plate in, then it covers up this open space, and then the next time the block moves up, the bottom of the pin rests on the plate, and that is pushed by the rocking block upwards, and that takes the pin with it and punches through the paper tape. So all the solenoids are doing is controlling these small fingers, deciding whether they are moved across to the right or in their resting position towards the left. And again, I'll do just a representation here. So they're arranged like this. So there is a pivot down here, they pivot at the top, and then the solenoid just sits here. If you energize the solenoid, it moves this plate up, which in turn pushes this to the right. It pushes the little finger underneath the pin, and on the next cycle it will punch a hole through the paper. If you don't energize the solenoid, this stays to the left, and then the pin will not be raised on the next cycle and no hole will be punched. And with this arrangement, if we look from the top, it means that for each pin the fingers themselves can be very narrow. They don't need to be more than, say, 0.1 of an inch wide. And then you lay the solenoids out in a grid pattern. So in this particular case, it's in a 3x3 grid. Obviously it's a lot wider than the width of the tape, and all you do is you arrange these small fingers so that they are the correct shape to align with each of the required hole positions, and then you just move them in and out in turn. It's a bit like a dot matrix printer, in that you just decide which of these particular little fingers that you want to be moved out. The actual spring tension is done by the springs on the side of the solenoids. So you've got little springs here, and then there is a damping rubber on the bottom, or they're supposed to be, and they normally break, and 2 of these 3 are broken and the 3rd is on the way out. They're only really rubber O-rings, so I can easily replace those. But they do need to be there, otherwise this will chatter. You can kind of hear it now, and make a lot of noise, and it won't return smoothly and cleanly to the home position. Okay, so that's the way it operates, and now that we know what we're looking for in terms of how it's supposed to be running, we can check to see if it's all turning the way it's supposed to. We can strip it down, clean it out, and then hopefully get it working in the way it's supposed to. Okay, so what I intend to do with this punch is to strip it down to its major parts. You don't necessarily need to go that far for normal maintenance, but because this unit's partially seized and I don't think it's had a service for quite a long time, then I may as well strip it right down, clean all the parts, free up the frozen sections, and then check that the belts are okay. So it'll also be a good way of looking at it to see how it works and look at the inner workings of the mechanism. So if you're interested in this old type of punch, then hopefully you'll find this a bit interesting to see what goes on inside these. So the first thing I'm going to do is take off the front guide plate. So this is just the plate that the tape runs under, and it's used to guide the tape over the sprocket hole. So it punches its own sprocket holes as it goes. The paper comes in from the back, and then once the holes are punched, the tape runs down under this plate, and the holes it's just punched are then used to advance the tape to the next position. But I want to get this out of the way so we can get better access underneath, and also gain access to the bearing that this is running on, because it might be this that's frozen rather than the motor. So I'll get this out of the way. Okay, so I've removed the front guide plate, and that exposes the sprocket drive. And what I'll do now is take off the rear guide plate, and then I should be able to remove the punch head and die block. Okay, so that's the rear tape guide removed. Now, as you can see here, there are various slots on this to allow it to cater for different width tape, and all you do is you move the guides to the correct mounting holes, and that will adjust for the width of tape that you're currently using. So the next thing I want to do is to try and get the punch block, die block and pins out. Okay, I've taken the main bolt out of the die block, and now I can just take the two bolts out of the solenoid bank. I have put a mark on here because the position of this is fairly critical, and it sets the position of the little guide fingers relative to the bottom end of the pins, and that does need to be fairly accurately set up. So I'll put a mark on here, and hopefully that will allow me to get it fairly close when I reassemble the unit. So now if I take these two bolts out, I should be able to release the solenoid block, and then the entire mechanism should come apart. So I should now be able to lift this out, and then this entire block should come forward and lift off. So that's the solenoid block, and then this should come forward and up, which it does. And so this is the actual punch block. This pad is just to hold lubricant and to stop debris falling down onto the sliding pins, and then the actual punch pins themselves sit in this die block and move up and down. You can just about see the ends of them through this little slot. So I will take this apart because I need to inspect the pins and see how worn they are. And then on the solenoids themselves, these are the fingers I was talking about, and when I depress one of the solenoids, you can see the finger moves out, and that's what allows the pin to engage with the eccentric drive. And because these are so light, the reason they get holes in is to make them lighter, and because they're so light they can also move very quickly, and they don't need much power from the solenoid. So I'll check all the solenoids independently. I'll take this top cover off. It might need lubricating and cleaning under here. It doesn't look like it's had a huge amount of use, but you can't always tell. And this arrangement here is to allow adjustment of the punch head die block relative to the solenoid block. And it's just basically a screwdriver slot system to enable you to move this back and forth. Again, I won't move this unless we need to when I reassemble, but hopefully it will all line up, won't need too much adjustment. Okay, so the next thing we have is the eccentric drive. So this is the eccentric that moves up and down and causes the punch pins to move up when they're engaged. This seems to turn fairly freely, but I will take the eccentric drive off and check the bearings. So we'll spin it round, have a look on the other side. And so what we have on this side is the main drive for the eccentric. That seems to spin quite nice and freely. The belt's a little bit loose, but it's not too bad. But probably, I think I'll probably tighten this. It's a bit too loose. Doesn't seem too badly warm. It's just too loose. But you can adjust the motor around. There are some slots, and you just slacken the screws off, move the motor out, and it will tension this belt. So this arrangement down here is a sensor. It picks up the position of the eccentric drive, the little vanes on the back here, and it's used to determine when certain actions should take place, such as when to energize the solenoids, when to de-energize them, when to drive the tape forward, that sort of thing. And this just feeds signals back to the control electronics, which we'll have a look at when we get onto the control board. Okay, so this all seems fine. Now, it will need cleaning. It's not too bad, just needs a general clean. Now, I've got a tensioner here for this belt, but I need to find out why this won't turn. So I'm going to take the belt off and see if I can get this out. I suspect it's just got some dirt and debris, and the grease in here has frozen up, so I'll get this out. I won't do it on camera, it's a bit messy, but all I'm going to do is slide the belt off. There are a couple of screws in here I'm going to take out, and then a couple of grub screws that hold this in, and then I can pull this off the shaft it sits on, and then pull this entire assembly out, and at that point I'll get back on camera and see if we can figure out why it's not turning. Okay, well, that came apart without too much effort. It was just this top bearing that had partially seized up, so by the time I'd got this disassembled, it started rotating freely. It just now needs a good clean and polish. And I'll do the same with the rest of this sub-chassis. I can adjust this belt, but unfortunately the other belt is beyond use. It's disintegrating, so I need to get one of these ordered before I can continue. And then once I've got a new belt, I can start reassembling this. We can look at the solenoid block and the punch block, see if they need adjustment or lubrication, give everything a good clean, and then I can get it all reassembled. But next thing, I need to find what size belt this is supposed to be and get a new one.